For thousands of years, humanity has looked toward the sun with a mixture of wonder and fear. Ancient civilizations built temples around its movements, created calendars based on its cycles, and imagined powerful beings responsible for carrying its light across the heavens. Today, we understand the sun very differently. We know it is a star, a gigantic sphere of plasma powered by nuclear fusion deep within its core. Its energy sustains nearly every form of life on Earth, while its magnetic activity produces enormous eruptions capable of affecting satellites, communications, and electrical systems. Yet the sun still contains mysteries. And one of the most ambitious attempts to understand them is NASA's Parker Solar Probe. Launched in 2018, Parker was designed to travel closer to the sun than any spacecraft before it. Its mission was inspired by a prediction made decades earlier by astrophysicist Eugene Parker, who proposed that the sun continuously releases a stream of charged particles now known as the solar wind. But reaching the sun is extraordinarily difficult. The spacecraft must survive intense radiation and extreme temperatures while moving through an environment filled with powerful magnetic fields and rapidly moving plasma. To accomplish this, Parker carries a specially designed heat shield. While the shield faces the sun, the instruments behind it remain protected. The spacecraft has already transformed our understanding of the solar environment. Its measurements have revealed turbulent plasma, rapidly changing magnetic fields, energetic particles, and structures moving through the corona, the sun's outer atmosphere. One of the greatest mysteries involves temperature. The sun's visible surface is thousands of degrees hot, yet its outer corona can reach temperatures of millions of degrees. Why should the atmosphere be dramatically hotter than the surface beneath it? Parker is helping scientists investigate that question directly. But imagine that, during these observations, researchers discovered something completely unexpected. Suppose the solar wind contained repeating fluctuations that appeared unusually organized. At first, engineers would probably suspect an instrument problem. Spacecraft sensors can produce errors. Data can be corrupted. Natural plasma processes can create repeating patterns. So scientists would compare the observations across different instruments and different encounters with the sun. If the same structures continued appearing, the mystery would deepen. Could the patterns be produced by a previously unknown physical process? Could magnetic fields be interacting in a way that scientists had not predicted? Or could the apparent organization simply be an illusion created by the enormous complexity of the solar environment? These questions would demand careful investigation. The most extraordinary interpretation would be the idea of stellar consciousness, the possibility that a star could possess some form of awareness. But there is currently no scientific evidence showing that the sun is conscious or capable of intentional communication. Still, the idea makes for a fascinating thought experiment. What would consciousness even mean for a star? A human brain processes information over seconds or milliseconds. A star operates on vastly different timescales. Its magnetic structures can evolve over days, months, or years. Its internal processes unfold over thousands or millions of years. If a star could somehow process information, its perception might be completely unlike anything familiar to humanity. It might not think in words. It might not experience time as we do. Perhaps its hypothetical language would exist through magnetic fields, radiation, plasma, and enormous changes occurring across its surface. But again, this remains speculation, not an established scientific discovery. What is real, however, is that the sun behaves in extraordinarily complex ways. Its magnetic field constantly changes. Solar storms erupt. Plasma loops rise and collapse. Particles accelerate to enormous energies. And the solar wind carries the influence of our star far beyond the planets. Parker is now traveling through this environment and collecting measurements that could answer questions scientists have asked for generations. The deeper it travels toward the Sun, the more detailed our picture becomes. And every new observation reminds us of something important. The Sun may be familiar because we see it every day. But familiar does not mean completely understood. It is a dynamic star capable of changing the environment throughout our entire solar system. And Parker's solar probe is giving humanity its closest look yet. The real mystery may not be whether the Sun is alive or conscious. The mystery is how much more there is to discover inside the physics of the star that made life on Earth possible. Every second, the Sun releases an enormous amount of energy into space. Only a tiny fraction reaches Earth. Yet that tiny fraction is enough to drive our climate, power photosynthesis, influence atmospheric chemistry, and sustain nearly every ecosystem on the planet. The Sun is not simply something we see in the sky. It is the central engine of our cosmic neighborhood. And Parker's solar probe is traveling closer to that engine than any previous spacecraft. As the mission continues, scientists are studying one of the most important questions in space weather. How does the solar wind become so fast and energetic? Near the Sun, the plasma behaves in ways that are difficult to predict. Magnetic fields twist and reconnect. Particles accelerate. Structures race outward through the corona. Eventually, some of these disturbances reach Earth. When powerful solar eruptions collide with our planet's magnetic environment, they can trigger geomagnetic storms. Satellites can be disrupted. Radio communications can be affected. Navigation systems can experience problems. And in extreme cases, electrical infrastructure can be placed under significant stress. Understanding these events is therefore more than an academic exercise. It is part of protecting modern civilization. Parker's measurements are helping researchers understand what happens before these storms travel toward Earth. Instead of studying solar activity only from a safe distance, scientists can now examine the environment much closer to its source. And that creates an extraordinary scientific opportunity. Imagine discovering that some of the strange structures in the solar wind are far more organized than expected. That would not automatically mean the Sun is communicating. Scientists would first investigate conventional explanations. Perhaps magnetic reconnection creates the repeating structures. Perhaps plasma waves interact with one another. Perhaps the Sun's magnetic field contains patterns that naturally emerge from complex physical processes. Nature can produce incredible order without intelligence. Snowflakes have intricate structures. Galaxies form enormous patterns. Crystal lattices organize themselves. And plasma can generate waves and structures through physical laws. So an unusual signal would need extraordinary evidence before anyone could describe it as intentional communication. That distinction is essential. The fictional idea of a conscious Sun is fascinating, but the real scientific story is already extraordinary enough. The Sun has an atmosphere that behaves differently from anything we experience on Earth. It launches streams of charged particles across the solar system. Its magnetic field extends billions of kilometers. Its activity changes over an approximately 11-year cycle. And its eruptions can influence planets far beyond our own. Parker is helping us understand this vast system from the inside. One day, its observations may help scientists build better models of solar storms. Those models could give humanity more warning before major eruptions reach Earth. They could also help future astronauts traveling farther into space, where solar radiation becomes a serious hazard. But perhaps the most profound result of the mission will be philosophical rather than technological. The closer we look at the Sun, the more obvious it becomes that our planet is deeply connected to its star. Earth is not isolated. We live inside the sun's extended environment. Its light reaches us. Its particles pass around our planet. Its magnetic storms can disturb our technology. And its energy has shaped Earth's history for billions of years. So when Parker approaches the sun, it is doing more than visiting another astronomical object. It is investigating the source of the environment in which humanity evolved. And perhaps that is the real lesson hidden within the mystery. We do not need to discover a conscious star to realize that the sun is extraordinary. We only need to understand it. Because every magnetic wave, every particle, and every burst of radiation carries information about the star that has illuminated Earth's sky for billions of years. Parker's solar probe is listening to that information. Not for a voice. Not for a message. But for the physical story written into the plasma and magnetic fields of our nearest star. And the deeper we go, the more chapters of that story we may finally be able to read.